Good afternoon, everyone. So here we are. This is the first session, and we'll be actually just going through, we'll be starting out with the whole project that is the payment building block. But this session will be related to an overview of where this project started, what was required from it. We'll give you some scope and expected outcomes from this training going forward. We'll give you a brief introduction of what is a payment building block, what was the expected functionalities that were demanded from it, and then how it has been implemented over Payment Hub, that is the candidate solution that we have used, and how Payment Hub also already has some existing external connectors through which the whole prospect of being able to access, send payment instructions anywhere can be accessed. So we'll be talking about that briefly. We'll walk you through quickly through the UI that we have developed for accessing some of the functions and to view what is happening. And then we'll again have a small walkthrough of the flow of G2P and P2G cases. We've just picked up a few, and then we'll walk you through them. And in the end, just a summary and question and answers. This is what our flow is going to be. So to start with, just to set the precedent, these are the people we envisage who would be interested in this training, the project managers, basically the implementation team. They need to know what the project is about and how it would be implemented going forward. So these would be a series of trainings. This is the first one into it. So what are some of the expectations we have that our audience would have the understanding of? They would have the basic understanding of the Govstack initiative, what it is about, what are the implications required for G2P and P2G payments, what would be the prerequisites, so to speak, what would be the requirements for it. Then some basic understanding of Kubernetes is essential because the whole system is deployed using Kubernetes. So some terminologies, especially in the upcoming trainings that is used. So especially for our third round, where we talk about implementations and deployments, we would strongly recommend people having Kubernetes and CI/CD and DevOps background. And then just some standard terminologies related to payment systems that would be required because that is what we'll be talking about. So first of all, the objective of this specific training is basically to give an overview because we'll be specifically talking about the terminologies related to DPGs and DPIs. So just to give why those are required and what is the standing of MIFOS on it, how we approach that problem to come up with this design for payments building block. So by the end of this training, we should have some understanding of mapping of the initial requirement and how that has been implemented. Some of the main terminologies, because they could be used interchangeably, but they're widely different. We wanted to clarify, we'll be mentioning Payment Hub and Payment Building Block. So Payment Building Block was actually the initial specification that was created by the Payments Building Block Working Group. This was the set of requirements that was set down. And to implement that Payment Building Block, we have used the Rails of Payment Hub, which is also called Payment Hub Enterprise Edition. And it is on this system that we have implemented the Payment Building Block solution. So Payment Hub itself had some functionalities already existing, which have been there for quite some time, but some additional functionalities have been built on top of it so that to specifically match the requirements of the payment building block. All right, so as I already told you, we have several versions already existing for Payment Hub, but the latest one on which all these requirements have been implemented is the version 1.13.0. And basically, these are the additional implementations that we have done over it. So we have now additional modules and services related to bulk disbursement. This not only just allows getting bulk batches uploaded, it breaks them into sub batches, then send them to specific DFSPs and get status updates from them. We have created another module which is related to identity account mapper. This is one of the most essential modules that we have created for the implementation of payment building block, because this is where whenever beneficiaries are onboarded to a system or registered in some other ministry of government or any other entity, they are allotted some functional IDs, but their financial addresses are saved in this database, and no other building block or other external entities knows that information. So for that purpose, the payment building block is essential and is dependent upon ID account mapper, from where the financial addresses can be get for the beneficiaries that are registered into the systems. We have implemented for P2G cases, we have implemented a bill pay module where the consumers would be able to pay their bills, like for example, taxes to the government. So APIs have been implemented and some functionalities implemented, which we'll talk about going forward. There is also the voucher management service implemented, for which we have created how the vouchers could be created in a certain way, then they could be issued to certain beneficiaries so that they could later disperse them, use them to pay for certain functionalities. And some certain UI enhancements have been done. We'll be looking at the UI that has been created and how to easily access it and navigate through it, so that authorized users can see what is happening within their payment building block functionality within the payment hub. So let's talk about the payment building block briefly, because this is what the initial solution was. So essentially, payment building block is basically a conceptual framework, which is working on the premise that this would be something that works standalone, and over here, other building blocks or other external entities could send in requests to verify whether this financial information is correct or not. So that information that is created or within the payment building block, it is not being sent anywhere else. So not just that, it should be able to be interoperable. So it should be agnostic of any payment, any other entity that is sending it request. It could be able to get requests from any of the other building blocks, any of the other DFSPs, or any of the other financial institutions. And then it should be independent of any physical infrastructure, so to speak, so that if there is any underlying infrastructure, and also because our design is based upon the Kubernetes environment, it is independent of that, so that it could be set up anywhere, considering that we need it to be adaptable to any jurisdiction or payment system as required. So that is some of the functional capabilities that were specifically required from this was that it should be able to help governments specifically in the G2P and P2G payments. So if, for example, governments have to make payouts for some social benefits programs, they should be able to utilize the services of payments building block and send out payments to their consumers. Similarly, if the consumers would have to pay some bills or taxes or some payments to the government, they should be able to use the rails of payment building block and send out those payments. The digital payments for government service, the payment building block should also be able to enable digital payments for government services, and not just enable them in the sense that one thing that we be doing is it just not enables them, it initiates them. It is able to verify the incoming information. It is able to match the incoming information with information that is stored within the payment building block, and then assist them in being carried out. Besides that, another thing that was very important was not just being able to transfer individual payments, but bulk disbursements as well, which is one of the most important ones, because if governments set up some sort of social welfare programs, or they have to give some periodic payouts, then it is much more feasible that bulk payments should be able to be done. So payment building block should have the capability to be able to send out not just single payments, but bulk disbursements as well. And those two through different channels, for example, through mobile money, through vouchers, and not just bank accounts. So all of these should be encompassed in this. And lastly, one of the most important goal was actually so that a payment building block should have a design such that it could be adopted by low income countries where conditions are still developing, because the main aim is to enhance inclusivity. So these were the main requirements that were set down for the implementation design of the payments building block. So we've just talked about the payment building block. This is just some extra information that we talked about. One thing which is very important is, which we talked previously also, it is that the DPG, a payment building block, should be such that once it is able to act, it should be able to act as an atomic unit. It should be a standalone unit. So it should be working such that any other DPG or a digital public good could work together with it, and together they could make an ecosystem called the digital public infrastructure, so that governments can set those infrastructure up and create for better systems.
DPI's digital public infrastructure really is the key bit that will enable this to be engaged and adopted across. What you can see here is the UNDP playbook, which, if you want more information on digital public infrastructure, we completely recommend reading in detail. It talks about how to set it out and do it. There's a number of key core functionalities that sit within a digital public infrastructure: digital identity, digital payments, consent-based data sharing, and there'll be others that come along as this gets developed out and more embedded. I think the key bit to focus on here is obviously the payments building block is going to be a key part of any digital payment, any digital public infrastructure system, and hence why it's been absolutely essential that as we've developed this, we've maintained its ability to be a DPG that can be incorporated into a DPI. And in fact, Payment Hub was recently certified by the Digital Public Goods Alliance as being a DPG with all the Govstack functionality that's included. So it is a DPG that can be incorporated into a DPI. So what you see here is the UN definition of what a DPI is, where it must resolve or assist governments to effectively perform sort of an administrative or economic tasks. And they're meant to be easily scalable, absolutely agnostic to the environment that they're sat in, and then adaptable to the jurisdiction. So you can see the alignment there directly back to the Govstack aims and the fundamentals of Govstack that we called out at the beginning. The payments can be made in many different forms, therefore, so that's how we interpret that to be. It should be available to provide support for critical services. It should be able to reach people and be lower cost, because that will enable uptake and inclusivity, and ultimately it will be a public benefit, a public good, and hence it will be owned publicly. Rather than us talk about it more, this is the UNDP definition of digital public goods.
You've definitely heard of digital public infrastructure, or DPI, but can you explain what it really is? Let's take a look at it through the eyes of billions of people at the risk of being left behind. Meet Amari. Amari needs to prove she owns her land, pay for government fees, and receive payments for various services. She needs to provide the Ministry of Lands a copy of her ID card, an authorization from her bank, and half a dozen other documents. Just imagine how much time she would save if she could access these documents with just a few clicks. The ministry could then also quickly make sure her documents are authentic. For this to happen, identity, credentials, and payment services must be digitized and connected with each other, both across ministries and private data providers like banks. This is exactly what DPI is all about. By digitizing more public and private services on common infrastructure, we will create more value for each of us. To actually make Amari's life easier, some rules must be respected. Think of a railway system with stations, tracks, and trains. Whatever the length of the train, the wheel spacing must be identical. Whatever route it takes, the signaling must be consistent. And whatever the train's schedule, time must be measured uniformly across stations. This guarantees the smooth functioning of the infrastructure and ensures scale-up from network effects by breaking down silos. The result? Travelers get to their destinations safely and comfortably. With built-in open standards that are reusable, not only does it become easier for Amari to access information and payments, but this infrastructure can connect everyone, everywhere, to other opportunities and services. With privacy embedded up front in the design, people can rest assured that their data will be kept safe and secure. The world over, countries are starting to build their own digital railways. The good news is they can pick among the best existing practices and adapt them to the tastes and travel habits of their people. The tracks we lay today will shape the infrastructure we will share tomorrow. So let's join forces and shape this new infrastructure towards ensuring that DPI is safe, accessible, green, financed, and future-ready.
So what we want to do here is just highlight how Payment Hub is a DPG meeting that. So the characteristics of a DPG, firstly, it must be open access. So Payment Hub allows open access. It allows access to any government entity or paid FSP to use its services as required. We use role-based access control. That's managed through Keycloak, although you could use other OAuth services if required. Therefore, it can be used by multiple entities, payer FSPs or aggregators to be able to form G2P or P2G payments. Payment Hub is open source. That is a fundamental principle of all the Mythos products, and it's implemented globally to various DFSPs with different payment systems, and we have a global community that supports it. And it's through that global community where we've collaborated, with Govstack in the specifications to come into this, as well as other contributors and other scenarios we've done that we meet the collaborative development characteristic. Interoperability is also key. So Payment Hub is developed over a layer of connectors that are defined by open API standards, and therefore those can be secured with adaptable gateways such as Kong, Nginx, etc., and allow for interoperability, being able to communicate on open APIs with various other systems and networks as needed. Payment Hub is absolutely agnostic of the end user's status, ethnicity. It does not discriminate in any way. In fact, by being open source, you can, say it promotes inclusivity. Also, by the implementation of the identity account mapper and unique identification numbers, now actually you're not even passing financial information back and forth between the registry and the payments building block. So it's non-discriminatory in even that data flow that comes across. Obviously, Payment Hub is designed for many different reasons. It can be used in commercial entities as well, but primarily it's there to support public aims as well, and enablement for the public. And finally, it's sustainable. So Payment Hub is designed to be scalable. You can implement it in many different models, as we'll see in some of the later modules, to be able to make sure that it's cost effective. It can be scaled up as a country or deployment needs to scale, and therefore reduce the overall environmental impact of the solution. Rabia, do you want to go through the DPG stack?
Yeah, so as we just talked about, we laid down the foundation for what the DPI goal was. So this is how Payment Hub is a DPG. We're just going to highlight it briefly over here. So not only does it do payment orchestration, it stores the information. This specifically over here, what you see is the Payment Hub Enterprise Edition that already existed with multiple connectors and multiple operations that it was providing. So this layer has been built on top of it. What we were just talking about, we've given you a UI. And then we have the ID account mapper. This ID account mapper alone itself is one of the functionalities. How it proves to be a DPG, because it is focusing on one task only, and that is to maintain the data, its privacy, and validate and verify it. And that data of financial address is not transferred to any other entity. So it's there. So then we have bulk processor, as we talked about, being able to disperse payments to multiple beneficiaries at one time, and then it enables a payment orchestration and passes the messages related to payments. Besides that, already we have lots of connectors and the use cases already in function. So not only is Payment Hub able to connect with multiple MFIs, it also has capabilities to connect with mobile payments, to connect with other connectors, especially like Mojo Loop connectors for account lookup services, for other services for payment systems. So this is a complete solution through which it is interoperable with multiple systems within the Govstack as well as outside the Govstack as well. So it is how it is working. Now, coming to the functionalities that were required from the payment building block, currently we have focused on two major use cases. One is the government to payment use case, and the other one is person to government. So for government to person use case, as we'll be talking later as well, we have multiple services that have been designed, and they together enable different scenarios to be implemented. For example, governments can make payments to beneficiaries for social benefits. They could disperse salary payments. They could create multiple programs. Right now, already in the sandbox environment, we have worked on the unconditional social cash transfer demo sort of has been created, through which this a process can be seen. And other than that, for person to government payments, we have focused on bill payment systems, and that too in multiple ways. One way is through push payment, where the consumer makes a bill inquiry first and then pushes payments through to the biller, and the payment building block itself works as the mediator of that information and to let the billers know that the payment has been made. So all that information, that business logic has been implemented in the payment building block. The second scenario that we worked on for the APIs that we've created on for P2G is when a biller or an aggregator itself, they send an RTP, request to pay request, and the payment building block sends that notification to the end user via their DFSP. So that is what we'll be talking about, and we'll see how that flow works going forward. So some of the benefits of using this payment building block structures, as we've been building upon this, that why we've come to this scenario and what is required. So what some of the benefits that we're talking about is, one is it reduces the administrative cost. Why? Because then the specific ministry, specific building blocks would focus on their core tasks only, and the other tasks that are not related to them per se would be left to the payment building block, such as being able to manage all this information that is related to transactions. Second, it allows digitization of payments, and it facilitates all the reporting, because everything that is passing through the payment building block or the payment hub, that is being logged, the reports can be generated, and then they could be reconciled. So all that overhead of managing that data is being managed by the payments building block. Lastly, it's not last but not the least, there are other benefits as well. It also enhances the efficiency of government, because again, as we said, specific government entities, specific administration has to overlook this process. Not everyone has to do it. So they would only focus on what payment information is being transferred from one place to another, rather than looking at the other information as well, such as registering a beneficiary. That is not part of the payment building block. They would just focus on retaining that beneficiary's information and passing them and verifying them as and when required. So these are some of the benefits of the payment building block. Now we come to the section where we will be talking about the architecture of the payment hub, the main solution that we have used to implement payment building block. We'll be giving you just a brief run through of what you can expect in this. We'll give you a brief overview of the architecture, how payment hub has been implemented, and how payment building block layers have been meshed into it. Then some of the modules that are there, which we have developed and worked on, and some of the functional capabilities of the modules. First of all, this is a very simplified version of the whole solution to give an idea of how this solution has been implemented. What you could see over here is that this payment hub, it was already existing. So it had already had payment orchestration flows, various connectors, and a whole ecosystem that was going on. Payment building block is basically sort of a logical layer that has been built on top of it, and it is now part of the original payment hub itself. Therefore, all the Govstack instances are now part of the mainstream as well. It is providing various use cases, as we've already talked about initially. So this is just an overview of what we're talking about. So basically, in essence, Payment Hub provides an efficient layer of business and operational logic. What it is actually doing is, because it's not initiating the payment, it is not processing the payments itself, but it is providing all the necessary business logic that is required to enable the payment to be carried out successfully. This is where the essence of the entire payment building block lies, because it is giving all the validations, verifications that are required to make a payment happen. It is the one which is communicating with a source building block or a source entity when the request comes to it, and sending that request to the requisite end party, for example, a DFSP or any other financial institution. And other than that, another major point is its interoperability. So it does not matter which protocol is being followed at the sources end, which entity is trying to communicate to another entity. Payment Hub itself is the major bridge that is enabling all of these communications to happen across the channels, as we'll be seeing as we go forward. Besides that, what else it can do? It is providing major integrations, like we'll be talking about the major connectors. There are certain operational controls that you would be able to get through the Payment Hub. Payment Hub is easily scalable and replicable. We have different charts which could be configured as per the requirements of the implementing authority. They can configure them, scale them. We give you the minimum requirements. You could always change them and deploy them as per your requirements. It has a strong BPMN implementation, so orchestration is easy. This could be again reconfigured, deployed as per requirements. And then there is, of course, the reporting and analytics dashboard that we'll be talking about in the later stages. So the basic reporting is there, which makes it easy for the operations team and the implementing team to see how the functions are being carried out. Some of the major modules that are there in the Payment Hub is first and foremost is the process orchestration that is done by ZPay. So it is the one that is enabling all the BPMN and everything to be carried out and make the payments and all the communication for transactions happen. As we talked about previously also, that we have many external connectors which are enabling the interoperability part. Excuse me. So we have Moja Loop connector. We have different channel connectors which enable the source building blocks to be able to communicate with different channels, for example, mobile money channels, for example, accounts, for example, different channels that are there. We have AMS connector, we have audit streamer, all the data that is passing through the Payment Hub is being audited, and that is being logged, and that could be data used for auditing purposes as well. Besides that, we have the operations app, which provides the UI, excuse me. operations app, which provides the UI to see the operations that are happening within the payment hub.
So next we look at the key architectural considerations. So these are the architectural considerations that we have of Payment Hub as the solution underneath. So it's designed to be run either on-premise or in cloud infrastructure, and to enable that easily, what we do is utilize Kubernetes within the architecture. What we do is have separate real-time engine and operations backend systems. The real-time engine itself is self-contained. It's highly available and fault tolerant. So if there is a fault that occurs, it can actually still complete transaction flows because it has resilience all the way through the way the real-time engine works. Orchestrating the microservices is built into the architecture. Now, the reason we did that is it enables better handling of issues such as timeouts, enables asynchronous events because of the nature of microservices. It also handles error situations and exception scenarios much easier. So a microservice architecture is how the whole system is built, even in the front end, that is built under a microservices architecture to be highly resilient and highly flexible to asynchronous events. The payment real-time engine also manages the state machine. So that uses the orchestration layer. And what we use Raft for consensus and log replication. We use RocksDB to actually store the value of the states. And then what we don't do is use any external SQL or relational database, which would sort of hinder the scalability of the solution. What we have is one engine that's bound to a single data center. What that means is it can enable high performance, low latency. It can minimize the issues from network failure scenarios. You could have multiple real-time engines running in parallel, and then what that can enable is you to protect against complete site failure. It can provide 24/7, 99.99999, keep going, availability, and obviously what it does is support this notion of independent engines that drive single DFSPs, and then obviously the routing can occur at switch level.
Yeah, basically, in a nutshell, we'll be seeing at the architecture itself, but in a nutshell, what Payment Hub does is it has multiple options through which it can handle the synchronous, asynchronous events, and all the live feed is being done through Kafka and being updated through the Elasticsearch, so that all the other services can have the latest data, and the data that is required is updated and new, and the system can work faster. So, so basically, just to put what we've been discussing so far, to put things into perspective. So Payment BB, as we talked about, it was the original requirements from the working group, Payment Building Block working group. So what it is, actually, it describes all the functionalities that were required, the APIs that were required for the implementation. And what Payment Hub does is it has taken all those requirements and implemented them on the system and handled them so that that functionality could come to life over here. So we'll be talking about as we go. This over here, this scary looking diagram is actually what the Payment Hub is. But this is again, we have given you somewhat of a simplified view, but so to handle that every functionality that is being given, we'll be talking about it in more detail in the upcoming sessions, but just to give you some idea of what we were talking about the architecture perspective previously. So all of this system is deployed using Kubernetes. So it is infrastructure agnostic. We have over here the ingress control through which security is implemented, in the sense that authorized entries can only come in. We have key cloak over here through which only people who are authorized, or the systems that are authorized, can access the system. There is either Kong or Nginx are used as the API gateway, so as to also not just limit the control and work as a reverse proxy, but also to enhance interoperability. So multiple systems could send in the requirements. Then this whole part, this is the payment hub itself, the bigger block that you see. Within it, we have multiple services and modules. This module that you see over here implements and talks about the payment building block APIs that we were talking about that were required. So we have bulk processor, we have the voucher engine, we have bill pay, we have the identity account mapper, which could be deployed separately also. And then we have channel connectors so that the payment hub could communicate with various channels. We talked about Kafka and ZB Orchestrator. ZB Orchestrator has all the BPMN that are required for payment orchestration and the transaction orchestration, which could be configured. Kafka is used for all that asynchronous payment-related communication that is occurring within the system and outside of the system, and that requires asynchronous updates to the database. Besides that, whatever information is coming, it goes to this block over here. This is the transaction processing block and consists of all the external connectors that we were talking about. There are multiple connectors. We'll be looking at them also briefly. So we have account management system connectors, which connect to the CBS of various FSPs, the Fineract connector again to access the core banking systems. Then we have Moja Loop connectors, lots of them. So we'll be talking about them, as well as it also provides the capability to connect with external payment switches if required. So it is over there. From the operations perspective, the main deliverable that we are giving is the operations app, which we'll be looking at shortly. And it gives an interface to the users, to the authorized users, to see whatever is happening inside the payment hub. For example, which batches are in process or completed. It allows creation of vouchers and some such. Other than that, there are services that are running, the Elasticsearch service and the RDBMS service, which are constantly being updated and live so that latest information is being communicated to all. We have the payment hub also has within its Helm chart the Kibana installation through which the reports could be generated and see. Other than that, there are notifications and message gateways are already up so that clear notifications and messaging could occur. Also, to make it easily deployable, the configuration management is being done through Helm charts. Those Helm charts can be deployed using the Circle CI pipeline. And then again, they are configurable. So as we'll go through the other sessions, we'll see how those files can be configured and what parameters can be configured and deployed as per the requirements of the implementers. And all the testing cycle is done via the Cucumber integration and component testing. The tests are written over here and they are also accessible. One thing which we left over here was how this payment hub is able to communicate with the external systems, which this block that you can see over here shows that via the connectors, the payment hub is able to communicate with the external parties, which are besides the building block infrastructure. So if any information, let's say any request comes from a source building block, it passes through the IMBB, which is the information mediator building block, is stopped over here at the ingress control. It passes through the verifications of the Kong and Nginx and verifies whether the request is valid coming from a valid resource or not, and then enters the system. So this is basically a brief overview of the architecture. Excuse me. So at the infrastructure level, Payment Hub has the capability to build customized digital financial services ecosystems utilizing MIFOS and Fineract, and can power switches. How customized? Because as we told you, the whole infrastructure, the whole system is highly configurable. And once the configurations are done, they can be implemented, deployed as per the requirements. So, and at the application level, Payment Hub provides external entities with reference channel applications that we talked about. As we saw over here, also we have connectors, and therefore it can communicate with mobile applications as well as other wallets and online banking. Those are some things which are existing for the Payment Hub and are in the pipeline also. David, if you would want to add something like this over here, please go ahead. Otherwise, we can just continue.
No, continue, please.
All right. So, yeah, one thing which we would also like to highlight over here, which we've highlighted ahead as well, is that we have APIs for Payment Hub to be able to communicate with the GSMA mobile money API so that it can easily connect with mobile money operations as well. So that is one of the use cases and requirements as well. So that is being fulfilled. And at its core architectural level, Payment Hub is a scalable system, as we have already told you, because in one of the upcoming sessions, again, we are going to show that we have multiple deployment models as well. So depending upon the requirement of the implementer, the engines could be the model through which it is deployed can be increased or decreased depending upon the requirement. So and it because it is utilizing ZB and it orchestrates microservices, so multiple workers could be created as and when required. And through Kafka, as we already talked about, that it ensures that all the latest information is being captured by the others modules and services in real time as fast as possible. So it enhances efficiency as well, even if it's a basic model that we'll be deploying. So other than that, as we talked about over here in the ingress type, so we have the API gateway over here, which is handling the incoming traffic as well. So it works as a load balancing as well, so that when we talk about its availability, it is not going to give you, it's not going to go down. So that is being handled through the ingress traffic controllers and all that. And besides this, we also talked about the SQL Server and the Elasticsearch services, which are also being updated in near real time due to the quick communication between Kafka and these services. And other than that, if there are any other services which do not require, besides the payment transactions, if there are other transactions which do not require direct routing through Kafka, those are directly communicating via the connectors. So again, as we said, the whole system is highly customizable and it could be deployed and configurable as per the requirement of the implementers. So we've talked about the operations app. We won't talk about it here. We'll show you how it works, the operations app, and how the people using it can see what is happening with their use cases. And again, because it's adaptable, configurable, it could easily be adaptable. We just had this sort of a disclaimer, so to speak. We've talked about Keycloak and Kong. So it's just for the deployments also going forward, when we'll be mentioning this, we are assuming that these would already be in place. We'll tell about how they are integrated with the system, but since they're more related to the environment rather than the application itself, so therefore these would be, we assume that these would already be in place as per the implementers requirements. And if required, we've given the links which could be followed to get more information of. Now we come to the external connectors that we keep talking about, because they are important in the sense that they extend the capability of the payment hub itself. So some of the connectors that we'll be talking about, the Fineract and MeFOSX connector, the MojoLoop Oracle for account lookup services, the MojoLoop Switch, the GSMA and M-Pesa. So we'll just quickly come to it. Above, we saw a basic, a very not very detailed, but somewhat detailed internal architecture of the payment hub. This is actually the payment hub when we look at it from the perspective of its functional capabilities. So how it supports interoperability and extend its capabilities is because of all these services and connectors that it provides. So we can see that it has various connectors. We'll be talking about, for example, payment scheme connectors. It has ISO 222 real-time connectors, modular loop connectors, and other payment connectors that are related to other payment schemes. There are then account management system connectors, for example, Apache Fineract connector, other core banking connectors as well. So let me just go ahead and tell you a little bit about the Fineract connector. David, if you would like to please pitch in, I think you would be better able to explain the Fineract part here.
Okay, so as you're probably aware, Fineract is a Apache software, which obviously Mythos was involved in the creation of before it went to the Apache organization, and it's still been maintaining and supporting the Fineract product since, and it has its Mythos X implementation, which offers additional UIs and interfaces and functionality over the top of Fineract. So Fineract itself is an example of a core banking system, and basically this would normally exist in, say, for example, with a central bank. If you're thinking of a Govstack instance, or any sort of banking entity will have a core banking system. What this, as an open source available core banking system enables is people to take the core functionality services and then add the value that they want on top of it. So this is why it's key within the connectors that we've built within it, that we can actually interface with Fineract. And you might be thinking, have we just interfaced with Fineract because it's one that Mythos supports? Well, actually, Fineract is actually underneath most of the major core banking systems out there. Even if they're branded and have different names, what you'll actually find is they're actually built on Fineract at the lower levels. So having that API connected towards Fineract actually probably covers a large section of the core banking systems out there. But we do allow the ability to have other core banking connectors within the solution as needed. And I think that's what you probably saw in that previous slide, and will be a sort of a common theme as we go through the different types of connectors here, is that by having that segregation of sort of connectors around the outside and the core functionality on the inside, what we're not saying is that you've got a highly proprietary code base you have to go and interface and do high scale integrations with every time a different type of connector is needed along the outside of that. Actually, you can just develop a very small connector to do it, and as we'll see in one of the later slides, that's exactly what we've done for mobile payments. The next connector we have is modular loop. So the reason we have a connector to the modular loop Oracle is to enable it to use that switch functionality for finding payment details for other services. So when we've created the ID account mapper, actually a key feature in that ID account mapper is the ability to look up an alias. So you could say this is the alias of those services. It could go away to the modular Oracle to be able to look up using that alias definition what the latest payment information are. And the reason for that is we're increasingly seeing developing nations looking to implement regional switches, which are based on that modular loop architecture and solution, and obviously the discovery is done through the Oracle at that point in time. We also have. Yeah, go for it, Fabio.
Sorry. I was just trying to highlight this point over here.
Yeah, absolutely. So the governance of the Oracle will be outside the scope of the payments building block at that point in time. And what you find with Moduloop is they have very detailed scheme rules, which those schemes must apply to. The next connector we have is connector to the Moduloop switch. So we've just looked at that in terms of the discovery and the alias for the payment details. But the modular loop switch enables connection to much wider networks of payment systems. And as we just said, typically we're seeing more jurisdictions or regions start to look at developing or deploying switch capabilities. There's a large number in sub-Saharan Africa which have just started deploying switch technologies out there to enable all the different core banking and banking partner systems to start working together to be able to do payments. Again, there's the disclaimer that obviously the governance of the switch and the operations of that is outside the payments building block, but it's absolutely key that we can interface with such things to enable payments. And then this was the example I was talking to earlier. So we have external connectors that obviously meet the GSMA standard to enable mobile money payments. And I know, one of the more popular mobile money schemes out there is obviously the M-Pesa. And what we've seen is a specific connector be built and developed within our community to be able to interface to Safaricom M-Pesa system. And I think that's the real advantage you see with the approach we've done here and that open source community system, that we will see more and more connectors coming along and being available within the community for specific systems when they need to connect. And obviously the fact that the Govstack implementation is actually embedded into the core of Payment Hub moving forwards means you can actually use any of these connectors as they come along in the future. So finally, this sort of slide sort of covers some of the use cases that are supported with those modular loop integrations that we've talked about. So it enables peer-to-peer transfer via sort of MSISDN. It enables biller request to pay, so that's a payee initiated transfer. All of that stuff is integrated into your operations UI, so you can see monitoring and actions and see the status coming back in, as well as allowing sort of incoming and outgoing transfers and request to pay mechanisms. Rabia, do you want to sort of go through the UI?
Yeah, so we are here. This is a little bit of the part where we can see. So we're just to give you an overview, this section will be going through. We have put in some screenshots of the UI that has been developed and how it works, just to give you a little bit of an idea of the flow of the use cases that have been implemented. First of all, just to emphasize that even to access the UI operations app, it goes via the Keycloak or whatever system the implementers have used for their Active Directory. So we have the credentials have to be created in the system. In our case, it is Keycloak. And if you enter the correct credentials, then you can go through. Otherwise, you are stopped at the onset. So we have that mechanism already. Excuse me. Once you log into the operations app, we have a very simple and clean interface right now. You can see three tabs. We have the Payment Hub functionality, which we'll be talking about. We have the vouchers, and then we have the account management. So starting from the basic one, the Payment Hub, this functionality would be talking about, if you click on it, and we are going to see how that works. It allows you to create, to look at all the batches that have been sent to the system already and the status that they are in. Then you could also create or upload batches, so to speak, and send them to the backend for further processing and see their status as well. Then you could also see that if a certain batch, which sub batches it has been broken into, and which transactions are there that are currently in the process. So we'll be looking at those as well. The voucher management functionality that allows three basic functions. It allows you to see the vouchers that have been created by the system so far. And then it also allows you to create vouchers by uploading the batches for vouchers, reviewing them if they're correct, then sending them to the backend for creation and possible issuance. And finally, this third feature that is provided is the account management. This is actually, you could say, a view of the identity account mapper that you have. It gives you no other functionality is there besides, because nothing else is required from the manual side as well. It displays the lists of all the beneficiaries that are registered in the system. Not in the sense that you have the complete information, but from the perspective of the functional IDs, for which government entities they are registered, what is their payment modality. So we are going to look at this. So basically right now, these three features, these three operations, which make the core of the G2P payments are available via the operations app. So first one that we'll be talking about is the payment hub functions. Once you click on this, it is going to give you four basic functionalities right now. It lets you view the batches, all the batches that are currently in the system along with their status. It lets you create batches how that you could upload them, or if you've already created them in the specific standard format, you could upload them to the system or drag and drop to the system and send them for creation. Then it also lets you see, let's say you've uploaded one batch, and then you want to see how many sub batches it is broken into. You would double click on those batches and you would be able to see how many sub batches that has been broken down into. I'll show you that shortly. And finally, it goes down to the granular level and lets you see each transaction and its details and status. Let me come to this so that you can see it. So you can see once we click on the Payment Hub tab, this is the main screen that you would come into. You can see that right now we have, this is just the list view. This lets you view the batches that have been in the system. As you can see, it over here, it shows the batch reference number. It tells the start time when the batch was uploaded, the time it took for it to be completed to uploading it, the source ministry or the source building block for which that batch was created, the total amount that that batch was trying to transfer, and the status of the batch. So this is just a viewing screen, which you can see through when you click on the main batches button. All right, I wanted to come to the create batches one, but okay, I think I've missed one slide, but let me just to give you some idea. Now, if I have these batches over here and I, let's say, double click on any of these batches, I would be taken to the sub batches screen. So let's say, for example, if this was, I'm just giving an example of it. If this was the batch that I was looking at, I clicked on it and I would be, sorry, coming back to the sub batches one, I could see that that main batch was broken down into two sub batches with the bulk amount for each of these batches. Now, this whole operation is being done at the backend in the bulk processor engine, which is getting the batches, and then it is breaking down into specific batches targeted towards specific DFSPs. All right. So now, and if I click on, let's say, a sub batch, double click on a sub batch, I would come to the individual transactions. This is the individual transactions that are already in progress. Again, you can see the batch reference number. You could see the start time, the time they were completed. It does not say the source ministry over here, but it would, and the payment amounts and the pair FSP for which it was targeted. The thing is about the transfer, the individual transactions, this is if I double clicked on any of those transactions, you could see a pop-up window, which would show you all the information that is present for that particular transaction right now. We can see over here that this transaction is still in progress. As time passes on, once it gets completed, the status gets completed, and that timestamp is shown there on the operations app. This slide I just put in here just to showcase that initially we had 3 completed transactions, but as time passed on, we got 4 completed transactions because the transaction got completed. So this was for the payment hub screen that we were talking about functionality. Now we come to the voucher functions. So the voucher, once we click on the voucher tab, I'll show you that tab as well. It gives basically just shows 2 tabs, but it provides you with 3 functionality. One is again, you could see all the vouchers that have been created by the system. Then it also lets you create vouchers by either uploading them or dragging and dropping them to view them, or if everything is okay, you click on one of the send data buttons so to initiate the creation of voucher process, or if the data is not correct, you could clear that whole data and it will be removed from it. One point that we would like to emphasize over here is for voucher creation process, and we'll show you also. Once the batch is uploaded on the system, it's much better that you review it once and clear it if it's not correct, because the voucher creation process works on the all or none principle. So if even one detail is not correct, or then the whole batch would be, the whole voucher creation batch would be rejected. So also, it provides you, the voucher engine also provides you the capability to download the template. So of course, because a certain template standard has to be followed. So within the operations app, there is the capability, there is this button over here. If anyone wants to download the template, they could download it, then create the vouchers according to the information required, which we've listed down over here just for clarity, and then it can be uploaded back to the system. I'll just show you briefly. Once we click on the vouchers a button, we come to this screen by default. This screen lists down all the vouchers that have been created by the system along with their statuses. Once that is done, if we want to create vouchers, we come to this screen. Over here, you can see the download template button. Also over here, you could see how you could upload a CSV file or browse a file from the system, from any entity, and upload this voucher. Let's see what we do. So let's say this is the template. I downloaded it. We, let's say, put in the data, and then we tried to upload it back. You can see that this was successfully parsed, and hence you can see all the data that was back there in my Excel file, CSV file. It is uploaded over here for us to review. Now over here you have 2 options. Right now this is non-editable, but if you think that there is something not right with this, it's better to clear the data. Otherwise, you can send the data. So once you clear the data, it means that this will no longer be relevant. The data would be gone, nothing else happens. But if you send the data, this goes to the back engine for voucher creation. So when for the voucher creation, we could see that the process starts, and as the vouchers start getting created, they come back to the main screen from where we could see the list of the vouchers, the one that opens by default. Excuse me. And finally, we come to the account mapper or the account management feature that is there. So the whole purpose of this feature is actually to let the users see what beneficiaries are there to and to filter and find if specific details for any beneficiaries required. So the operation app, once you click on it, this is the page that opens up. Right now, when I took the screenshot, we just had one record in it. So that's all you can see. It shows the government entity for which that beneficiary has been created, the functional institution for which that is. This is the functional ID, which was generated when this beneficiary was registered at some source registration building block. And this over here is the financial address. Now, this is one of those key information parameter that we talked about that no one else has. Just the payment building block, payment hub has it. And payment hub would be working to verify that whether this functional ID matches with this financial address and whether the information is correct or not. And over here in the last column, you could see the payment modality. Right now it says mobile money. So what it means is, excuse me, I'm so sorry. What this means is that once, if let's say payment has to be dispersed to this particular beneficiary, the method through which they would be getting their funds are in some mobile money wallet at the end of at this financial address. Besides seeing this, you could also use the filters that are over here. I've tried to put a blow up of the filters over here. There are various filters available through which you could find specific information. For example, you want to look at the beneficiaries that belong to a specific financial institution, or maybe you want to search a certain functional ID. You could do that through the filters options that are available over here.
I think, well, maybe gets a drink. I think the other key things to highlight through here. So you've seen the creation of batches, you've seen the creation of vouchers. This isn't an interface that is actually talking via a different back end into the system. What this is actually doing is giving a UI experience to the APIs that exist underneath. So we fully expect that in an implementation, most of those batches would actually go through the API. You wouldn't have someone sat there uploading files into the system. And equally with vouchers, that probably would be driven via an API, and then obviously the list of voucher information would be sent back through the APIs to the voucher printing mechanism or the QR codes you might want to generate or whatever else on the back end. So don't think this is creating a backdoor into the system. The reason we have these functionalities is it's really important as implementers, once you've got a system up and running, to be able to add batches and be able to test it. So we probably would see this create batch, and we'd probably see the create vouchers being more used during that implementation phase to test the functionality out in the system. And obviously, because we have our back behind all the roles within this UI, you can easily enable that for testing and then remove those features from certain groups of end users if you don't want them to be able to create batches to perform transactions, for example, once it's deployed in a production use case. Okie doke. So next, what we're going to do is walk through just in a little bit more detail some of the G2P and P2G use case scenarios before we sort of go over to a recap.
So before we go through the flowchart, just wanted to give you this diagram. I suppose all of us have seen already, but just to give you an idea of what a big ecosystem that we are talking about here. So it's not just one system, how it is connected from end to end. So these are the, let's say, I would want to say zones that we'll be talking about. For example, we have at one end some of the external entities, some other building blocks, because these will be used in the walkthrough of the flowchart. So I just want to give an overview. So at the left end, we're talking about source building blocks or government entities. Then we have the payment hub implementation of the payment building block. Then it talks with via external connectors. It talks with external systems to some sort of pay infrastructure at the right end corner. So these are the different hops that we'll be talking about. We'll start with one of the basic use case scenario, which is the beneficiary onboarding. So before we start with this, one thing which we have to talk about is the prerequisite to this is that we are assuming that some information, some work is done outside of the payment building block. Let's say in this case, for the beneficiary onboarding, this initial part is something that would be done before the system, before the beneficiary gets onboarded into the payment building block system. So let's say we have a registration building block. This over here is the external building block. So we have a registration building block to which some beneficiaries come, and we are right now, let's say, talking about a government trying to disburse salaries. Before they can disburse salaries, they have to register those people in its system. So the beneficiaries are recorded into the system, registered into the system via whatever process that registration building block is employing. Once that is done, the registration building block allocates certain functional IDs to each of the employees. Now, these functional IDs could be unknown to the beneficiaries. They could be known, but as design would suggest, it depends upon the implementation style design of the registration building block. So this functional ID is supposed to be allocated to each employee, and that functional ID is saved in, let's say, a payroll registry for a registration building block. So this would be something, a system to which the government employee would later go on at a later date and select the employee that, yes, this employee, or this functional ID I have to pay certain amounts to. Once they have been saved in the payroll registry, that information via the information mediator building block is sent to the payment hub side. So the information mediator building block is carrying this. This is being done via the API of the register beneficiary. So the information that is being sent is, besides the security parameters, it's sending the functional ID, it's sending the basic account details and modality. This is something which has been shared initially via the registration building block. Before that information enters the payment hub, it goes through the zone that, if you recall from our earlier diagrams, also it goes through the payment gateway, the Kong and Nginx, and goes through the the key cloak and everything to ensure that the request is coming from a valid resource. This validates whether the information is coming from someone we trust. If it trusts, it sends it ahead to the payment building block, payment hub. Otherwise, it responds, it rejects the request and sends it back to the registration building block. Let's say the request is validated, it goes to the payment hub. In the payment hub specifically, this request lands in the category of identity account mapper. It falls under the jurisdiction of this service, so to speak. So identity account mapper receives the information, and then it validates, performs some validation. For example, the basic validation that it performs is to check whether this functional ID is unique, so it could not be duplicated. So one functional ID is allocated only once. And then once it makes this validation, if it is correct, it goes on to the next step. If the validation checks fail, it goes to, it just lists down the fail cases. All right, so what is happening? One thing which we cannot see from over here is that this request for beneficiary onboarding could be done in batches. So a complete batch is coming, and this validation is being performed for all the information, all the beneficiaries that were being done. So whichever passes goes on to the next step, whichever fails is just noted. And again, it is also packaged at the end of this process. A package API of status is made in which it lists down the number of failed cases. So the cases that are successful are already there, but all the failed cases, they are packaged in that API and sent back via the access control system, via the IMDB, back to the registration building block to tell that, yes, these were the number of failed cases, and then those failed cases could be repackaged and sent again in another round as and when required. So this is how the beneficiary onboarding comes. So of course, certain APIs have been used over here, which we'll be talking about in our upcoming sessions as well. We'll go into the details of those APIs as well. Then we come to the next case about the bulk salary disbursement. So we were basically building upon this case. So before salary could have been dispersed, prerequisite is that those beneficiaries, those people have to be registered in the system. That has been done in our previous use case. Now at a future date, the people have to be paid, the beneficiaries have to be paid. So what happens is the government employee logs into its registration building block. It creates a badge, and again that badge could be in the form of an API, it could be in the form of as we said, a file, but it has a certain standard format on which it is made. The information it gets from the payroll registry. And the only information that is included in that batch that is created is the functional ID and the program ID, apart from other requirements of the API, but these are the only information. You would notice at this time that no financial address is being sent, because essentially that financial address is not saved over here. That is only saved in our payment hub in the identity account mapper. So the batches are prepared either through API or through a file. We have APIs for this, which we'll be talking about later. It is sent via IMBB towards the payment hub. Again, it is stopped at the access control zone through Kong or Nginx, and it passes those validations. If it all is well, then that request is sent to the payment hub. At the payment hub, the request first lands at the bulk processor, which you could see over here. What it does is that it debulks it. It first validates the batch that it is received, and it debulks it. So it breaks down the main batch into smaller sub batches, which are targeted towards specific DFSPs. Once it has debulked it, it sends the information for validation and to fetch the financial address information from the identity account mapper table. Now, this is where the account lookup service that we were talking about happens. In this table lies the information for each functional ID. It has its corresponding financial address and payment modality, as you would recall we saw in the UI as well. So what happens is both these things are happening at the same time. If the validation had failed, it would send back a reject. But if the validation had passed, it would ask the the identity account mapper to send back the financial information against those functional IDs. The identity account mapper resolves those functional ID addresses, and then it sends back to the bulk processor. So that bulk processor adds the financial information for each FID, and then it uses those sub batches and sends it to, as we talked about the connectors previously. Why? Because this is how they are being used. It sends to the connector, which to the scheme connectors, which will be communicating with external systems of the payer FSP. That connector sends this request to the payer FSP. Now, this request is right now the instructions for payments have not passed. Right now, one more function that bulk processor does is it checks whether there are sufficient funds available in the payer DFSP so that salary could be disbursed. So all of these, before they are sent, the payment instructions are sent, this request for fund availability is sent to the payer FSP via the scheme connector of the payment hub. So payer DFSP, it could be any central bank or any other bank. It checks for the availability of funds, which again is one of the assumptions that those funds have already been made for specific programs. It sends and we are assuming a happy flow. Therefore, it checks the funds and says, yes, their funds are available. And if the funds are available, the connector sends back the request sends a positive auth response to the bulk processor. If the funds would not have been available, we would have sent back a rejection. Otherwise, if the funds are available, bulk processor receives an auth. And then again, it sends a request to the scheme connector that please send all of these sub batches, which are targeted towards different DFSPs, payee DFSPs or payment modalities, and initiate the transaction, the payment disbursement. This request from the scheme connector goes to the payer FSP, which uses its own external payment system to initiate the payment. You would notice that this part of actual payments occurring is not within the realms of the payment hub. This is carried out externally by another system. So payments occur to all the various DFSPs, and they are handed out to the beneficiaries as and when appropriate as per their arrangements, excuse me. So once the payer FSP has disbursed the payments, it is now required to send a status back to the payment hub. Once it has dispersed it, it sends back a transaction status. Again, we have an API for this, which we'll be talking about later. And that Scheme Connector receives the transaction status updates for different batches. And you could also relate this to the UI where we showed you that different transactions first was in progress and then it was sent as it was set as completed. It was based upon the status updates that it was receiving. So it receives the updates, it sends it back to the bulk processing engine. It tells it that yes, this transaction status is updated. Now there are like two things which could happen. One was this is the operations web app view, which we were showing. It's an optional one. If you are viewing the transaction progress on the operations app, you could see that the transaction status has changed from in progress to it becomes to completed. Otherwise, it could also, because we are providing those APIs, the initiating building block or the source building block could access that status, that API, and it could be updating it at its own, and it could show it at its own UI or as and where required. So this is how the bulk salary disbursement use case occurs. If there are any questions, or we could take them later, I could proceed.
Let's proceed. Yeah.
Yeah. So this again, for voucher, we were just because we wanted to give an initial idea. So for vouchers, we've taken up the use case for scenario for bulk voucher creation, because after that there are various things. It depends upon the discretion of the implementer how they want to go about. But this whole creation process can give an idea of how this specific functionality is working. So starting initially, we have to, there's again one prerequisite or an assumption that is made that the payer FSP, like in the bulk disbursement as well, some provisioning is done for vouchers. So before vouchers could be created, it is important that the government entity or any source building block who is going to be creating those vouchers or creating those programs, they provide enough funds for those vouchers, because only then they could be validated against that fund and vouchers could be created. So this over here, what you see is the prerequisite step before it actually starts. So this whole yellow part that you see over here. So this is the prerequisite process. So source building block ensures that sufficient amount is provisioned. Payer FSP has that amount set aside for voucher creation and disbursement later on, and the payment hub is knows about this amount so that it can make the validations later. Now the process starts from over here. So voucher creation process is initiated through the source building block. Again, as David was telling you initially, it could either be, let's say, through a file upload, but we have APIs as well, and that is what we're assuming. So it could be two ways that we're talking about right now. We are saying it could either be through an API or through the operations app. Irrespective of that, the request is generated. The information mediating building block sends that request towards payment hub. Again, this is stopped at the ingress controller, and it checks whether it is for the app or API. All the source controllers, the control managers checks. So if it is this request is for the app, it will route it towards the operations app. If it is through an API, it would send the request directly to the voucher engine. So let's talk about both quickly. If we were uploading a file or initiating it through the app, we will be accessing the voucher upload screen. That is how it would have started. Or if we would have been through the API, then the voucher engine would invoke that voucher creation API. It would start either way. It will give the initial user a screen or an interface or a starting through which they would be able to start that whole process of voucher creation. So Payment Hub sends back the response for this back to the source building block, to the initiator, saying that yes, oh, it's all right. Please start your process of sending the vouchers. So someone from the source building block would upload the API or the file, create that voucher batch, and send it back to the payment hub. Again, when it lands over here, the controllers try to see whether it's targeted towards the app or the API. If it's targeted towards the app, it parses the batch as we showed you in the UI screenshots over there, parses the batch, and the user can see whether it's correct or not. Once it's parsed and you click on the send data button, not the clear button, send data button, again, this goes back to the voucher engine. So if it was an API, it was directly coming to the voucher engine. Otherwise, if it's coming through the app, again, it's routed eventually towards the voucher engine, where it passes through some of the validation checks. One of the validation checks, as we talked about, is where it checks whether there's much amount is provision for the voucher creation or not. So if it fails the voucher validation test, it sends back a rejection. But if it passes the voucher validation check and everything is fine, it updates it in an API and or the message, and sends back and creates that packages that response and sends it back to the source building block. So what we were actually trying to show over here is the way voucher engine is working. Once those vouchers are created, it requires specific data. They are in a pre-active state, which can later be activated, which means they are issued to the beneficiaries, and then they could later be used as form of, they could be used to make payments for certain requirements as and when required. All right. What I was just talking about briefly. So for a voucher, this is actually, once the voucher is created, this is its entire life cycle. Once that voucher creation request is sent, it is in a pre-active state. There may be conditions where when the vouchers are created, they are already in an active state, but right now that is still something in the progress. But right now they are in the pre-active state, and an API and a call is done to make the vouchers active. Once they're active, it means they could be disbursed and utilized. So once they're in active state, it could also happen that the voucher may get canceled, so that if a person goes to redeem it, they would not be able to do it. Neither would they be able to use it if the voucher is expired, it's gone past expiry date. And once, or if it has been utilized. So any voucher could be utilized only once, and for that exact amount for which it has been created. So these are some of the design considerations that have gone into creation of the voucher. Now we come to a sample of the P2G scenario. This is related to the bill payment. Excuse me. So for bill payment, what we did was to explain this, we did not utilize the usage of IMBB or the connectors right now. We've just mentioned them briefly because, again, this is dependent upon the implementers, how they want to go about implementing this scenario. But we just give you an idea of the modules and the steps that are involved in the bill payment system. So for bill payment through push payment, this has to be initiated. Payment Hub only communicates with the DFSPs. It does not communicate with the end user. So anytime we are referring to a payer FSP or payee FSP, we're essentially indirectly mentioning to the end users who would be eventually getting them, but that is beyond the scope of Payment Hub itself. So a payer FSP initiates a bill inquiry. Before a bill could be paid, right now we're talking about scenarios where anything there is a certain bill number or an invoice number has been generated and has been shared with the consumers payers who would be paying the bill. So they already have a certain number, either through paper invoices, or either through SMS or either through their apps or in any way. So what they do is they initiate bill inquiry request, they enter the bill ID. Bill ID goes to the payment hub, specifically lands in the bill pay service. Excuse me. So what bill pay service does is, because this bill ID, this is very essential. It uses its prefix. Let's say if there is a bill ID of 10 digits. So perhaps the first 4 digits identify which biller or an aggregator this bill is targeted towards. So what bill pay service does it uses that prefix. It goes into its table where, again, it's kind of like an account locator, so to speak. It's a small service within the bill pay service, within the payment hub that has been implemented. It takes those first 4 or how many digits and maps it onto a specific address of a biller or aggregator. It fetches that address, and then the bill pay service sends a request to that address towards certain biller or aggregator. At this point, nothing has been done, or the process has been done on the no information of the bill itself is retained within the payment hub. It is just locating the address and forwarding that request to the biller or aggregator. The biller or aggregator receives the bill ID, it searches its own system, comes up with the bill details. Specifically, we've asked for at least these details to be included. For example, the bill status, the due date, the amount at the time of due date, amount after the due date. So those information are loaded into the API and sent back to the payment hub. The bill pay service receives the data and passes it back to the payer FSP as is. Now, at this point, this is at the discretion of the end user themselves, whether they would go ahead and pay the bill or just abandon the request. For that purpose, sometimes we have in real life, we've come across situations where people call lots of bill inquiries, and then they don't go ahead and pay it. For that, those have to be handled at the payer FSP's end. Sometimes some penalties are put on, sometimes some notifications are sent, but this has to be handled at the end of the payer FSP. So if the person does not pay the bill, then that's that. However, if the person decides to pay the bill, then the payer FSP and its user, they follow their own external path. They initiate the payment with their existing payment system, and the payment is made. Once the payment is made, now it is on the onus of the payer FSP that it generates a certain payment reference ID, or let's say a receipt number or something, which it will now transfer back to the payment hub, so that the payment hub could let the biller or the aggregator know that they've made the payment already. So at this point, it is not necessary that the biller aggregator has received the payment per se, but it receives the notification that yes, your bill has been paid. And so you should update that status, which we initially sent as not paid to paid. And you could later reconcile from the reports and get your money from whichever mechanism is already in play. So payer FSP takes that payment reference ID, it sends it back to the bill pay service in the payment hub. It sends it to the biller aggregator. However, the catch over here is, which you can see over here, is that since the payment has already been made at the payer FSP, and only then, if the payment was made and the payment reference ID was generated, only then the payer FSP is sending this notification. Therefore, it is very important that this notification that we send ahead to the biller aggregator is sent kind of like an advice, and it has to be acknowledged one way or another. So if the biller aggregator acknowledges that request and sends back a response, which we'll be talking about shortly, all right. If it does not respond within the set time, then a loop is set so that the bill pay service will again send that request until it receives a response to it. Now, when we're talking about the response from the biller aggregator, it may seem that it would always send a yes or okay or something, but that is not the case. The biller aggregator could also send a negative response to it, that which would say that it has not marked the bill as paid, but it would be sending a reason along with it. So there could be multiple reasons. For example, the bill could already have been marked paid. Maybe some two people tried to pay the bill at the same time and one got paid and the other did not get paid. In that case, this opens up scenarios for disputes, which is again out of the scope of the payment hub itself. It could generate a report or for reconciliation, but that would be handled by the payer FSP at its end, how that is managed. So the biller aggregator sends the response, it sends it, payment hub receives it and sends it back to the payer FSP. If the bill was marked paid, yes, it's that the transaction is finished. But if it's no, then it would initiate alternate adjustment processes, whatever that may be at the between the payer FSP and its customer. We come to the final scenario for P2G. This is about initiation of the request to pay notification. So this process actually initiates at the biller aggregator end, and this does not require a bill inquiry. So this is through RTP, request to pay. What happens is the biller aggregator has to is already registered with the system and can initiate request to pay. What request to pay means is that a biller aggregator, once they generate a bill, for example, they can send that to an end user through their payer FSP over the rails of Payment Hub. And that request or notification which they send could includes the financial address of the payer. It includes the amount. It includes all the information that we had initially tried to access from the biller itself in our previous scenario when we were initiating the bill inquiry. So for this scenario, we again have two options. This RTP could be sent either directly via to a payment to the payer's account by entering their account information, or it could be sent via an alias. Now, what happens is it initiates the request, it sends it to the payment hub. Bill pay service receives that notification from RTP. It checks whether it is through alias or an account. So within this API, we already have the checks. It checks for the flag. If it, let's say, through an alias, then as we talked about previously, again, the connectors come in handy over here. This request could be sent to one of the Mojo Loop connectors. It could be any other connector as well. If the jurisdiction in which this is implemented, they have some other account lookup service, it would be directed towards that. But if not, for reference purposes, we've used the Mojo Loop connector. So it sends this request to the Mojo Loop connector, which sends it to the external processing zone. It sends it to an Oracle, Mojo Loop Oracle, perhaps, if it's Mojo Loop, to resolve that address. It looks through the alias, finds the financial address information, it returns it to the connector, and the connector returns it back to the bill pay service and says, yes, here is the financial address which you're looking for. So in both cases, if it was direct account or if it has been resolved by the account lookup service, that request is sent to the payer FSP. So Payment Hub sends request directly to the payer FSP, who is supposed to, because these are asynchronous calls, it responds back with an acknowledgement that, yes, okay, I've received the notification. I'll let my customer know, which it lets the customer know through its app or whatever mechanism it has. And the customer, meanwhile, either accepts or rejects that notification. So at this point, again, one thing which I have done, sorry, my cursor is not working well. So at this point, one thing which is important to note over here is if the customer accepts the notification, it does not mean that the payment has occurred. Right now, it is just accepting that, yes, okay, I've received your notification for RTP and I am willing to pay through that RTP. So what happens is the customer accepts or rejects the notification and lets the payer FSP knows, and payer FSP returns the response to the RTP notification back to the bill pay service, right? And the bill pay service then passes on that information, that whether it has been accepted or rejected via the API back to the biller aggregator, so that it would know whether it would be receiving a payment or it would not be receiving a payment. So what we've overlooked in over here is that, let's say if the customer has accepted the RTP notification, what would happen is at that some external zone, it would initiate payment as we did, as we saw over here, this, and it would initiate external payment through the external payment system, whatever is the way. And then the biller, and then the payer FSP would be would let the payment hub know about the bill being paid through these steps which we were talking about initially. So essentially this process repeats of marking the bill paid at, and if the customer rejects the RTP notification, it says yes, no, I don't want to accept it, then that request is rejected and the transaction is finished. One thing which you can see over here, this orange highlights, uh, because this is again an asynchronous process and sometimes the response may not reach. So we have provision for getting a status check APIs. If, let's say, the biller aggregator does not receive any response to its request because it's waiting for the response, in the meanwhile, it can send out a status update request to the bill pay service. With bill pay service again sends out a status update request in itself if it itself has not received answer to its notification, and it can check and then return whatever the response is from the payer FSP back to the biller aggregator. So there is provision that if RTP notification response is not received, a status check could be done as and when required by the biller aggregator or by the payment hub itself if it so requires. Was the walkthrough for the flowcharts. We have a video to show an end-to-end process.
Welcome. In this demo, we're going to show how the Mythos implementation of Govstack Payments Building Block, when integrated with core banking systems, can enable G2P payments to real wallets. The government of Wakanda has a number of ministries that need to make payments to individuals. The Ministry of Social Welfare has two programs. The first provides an education allowance, the second makes an unconditional cash transfer to citizens. The Ministry of Health also has a program to provide maternity benefits to certain beneficiaries. Our demo will show how with a DPI architecture such as that shown, the government of Wakanda can make payments to its beneficiaries. The government has implemented a Govstack approach, using the Mythos implementation of the payments building block. It has connections to the Central Bank of Wakanda, which holds the payment accounts for each of the programs. The Central Bank of Wakanda uses FINERACT DPG as its core banking system. The regional switch is provided by Moduloop, which was deployed within the region. This switch has connections to DFSPs that the beneficiaries have accounts with. The payees could be a range of Momo or bank accounts. In this instance, they're also using FINERACT for their core banking systems. The beneficiaries may use OpenAPI mobile banking or mobile wallet applications such as those provided by a range of open source providers. Initially, the programs have been set up on the payments building block with payer accounts associated with each program. We have also set up beneficiary accounts across the DFSPs, representing Momo or bank accounts. You can see the program accounts are funded, but currently the beneficiary accounts have no funds. As beneficiaries are registered, they are registered in the ID account mapper. This associates a financial, Momo, or alias account against the beneficiary ID. The beneficiary ID is unique per beneficiary for each program. To populate the ID account mapper, the Register Beneficiary API is used. Here, you firstly see the ID account mapper is empty, but as we send the data via the API, it becomes populated. Here is the data we have populated in the ID account mapper via the API. The government's registration system can update or add additional beneficiaries at a later point if needed. When the government of Wakanda needs to make a payment to beneficiaries in its program, the government system will send a bulk list of transactions to the bulk API of the payment building block. Here is the set of transactions we will process. You can see it is just passing beneficiary details rather than financial account details. The building block will then map these beneficiary IDs against the financial details held in the ID account mapper. It then creates a set of sub-batches of financial transactions for each DFSP to process. The status of these can be seen on the batch and sub-batch screens. A list of transactions and the status of these is also visible on the transaction screen. These sub-batches of transactions are passed via the mod loop switch to the payer DFSPs. If we look at the Fineract UI of the DFSP, we can see the balances having changed in the DFSP accounts for the beneficiaries. These are the balances that occurred from the set of transactions we showed. We can see the accounts corresponding to the programs have been debited, but the accounts corresponding to the beneficiaries have been credited. End users can also see their balances on their mobile banking applications connected to the DFSP accounts. In this case, the balance shows the $400 credited to the account of a beneficiary of the Education Allowance Program, set up by the Government of Wakanda's Ministry of Social Welfare. So in this demo, we have shown how a digital public infrastructure based on open source DPGs and a Govstack Payment Building Block implementation can support making government payments in a G2P program, thus increasing financial inclusion and enabling cost-effective and scalable ways for the government to make payments to beneficiaries.
Yeah, so that's essentially, this is just an overview of where Payment Hub EE is being deployed all across the globe. David, if you want to add something over here.
Yes, this is basically showing the scale behind Payment Hub EE, which is obviously the candidate solution that we've provided here. So you can see that it's used in a number of different scenarios across all the major continents. It's used in both commercial deployments, as we can see with SEPA and the ISO 20022 integration. As well as being used in sub-Saharan Africa, for example, the M-Pesa 1 Acre Fund deployment and PIX out in Mexico. So this is just giving you some idea of the scalability and what you're now tapping into as part of the community. So as things are added to the community, these all go on to benefit the Govstack solution. The next slide.
Yeah, so this is just an overview of what we've covered over here. What are the digital public goods? What are digital public infrastructures and building blocks? And how is Payment Hub adapted to become a digital public good so that it could work as a payment building block as per the requirements from the working group? And what use cases does the Payment Hub offer? We've looked briefly upon the scenarios also for those use cases for G2P and P2G operations. Then how Payment Hub's capabilities can be extended through the external connectors and how useful they are. We just saw the scale and the interoperability and the possibilities that we could have through the connectors that are available. And we also briefly saw the capabilities of the operations app because seeing is believing, so to speak. We also went through the scenarios, flowcharts of the scenarios to understand how actually within the payment hub itself, which modules are being invoked to carry out the certain transactions and capabilities. Just to give you an overview of the upcoming sessions, right now we have decided to have, we have planned for 5 sessions. This one was the first one. The upcoming session is planned for exploring the technical structure of the payment hub. So today we touched upon it briefly. In our upcoming session, we are going to open up the architecture and go through each block one by one and try to see how it is being implemented, where it is being used. And also we'll be going into a bit of details about the APIs that are implemented for the payment building block requirement. And we'll be talking about their inputs and outputs and what to expect from them. Then in the third session, we are looking towards the implementation and deployment of the payment hub. This would be a little bit more of a technical session where we are going to walk through the steps of deploying a payment hub instance and where things could be configured, what could be updated, what are the infrastructure requirements and some such. In session 4, we'll be talking about testing a payment hub implementation. So we'll be taking up the scenarios, end-to-end scenarios, pick them up and just walk through them, that this is a possible way to check them and see what steps are occurring, what are the prerequisites and what should be the outcomes. And finally, we'll talk about the reports and service and warranty stuff. So this is just a roadmap so that, right now we're looking towards number 2, and that's it. Questions, please.